So here the next part of the discussion, based on atoms are the smallest particles. Atoms are made up of smallest particles based on their combination. When the atoms combine in the various combination, here we have to study something about laws of chemical combination. If you go for laws of chemical combination, here first one is law of conservation of mass. Law of conservation of mass. Law of constant proportion. And also law of multiple proportion. Law of multiple proportion. So go for law of conservation of mass. If you go for the law of conservation of mass, the first one here, if you go for law of conservation of mass, if you take, it was given by Lavoisier, proposed by Lavoisier or explained by Lavoisier. It says that what is the principle involved here? We can say that matter is neither created nor destroyed, and the total mass of the substance is conserved. When it is being transformed from one form to another form, the total mass of the substance is always that is conserved. Conserved means remains constant. So what is happening here is the molecules are the substances which chemically react. Substances which chemically react. Substances which chemically react are called reactants. Substances which chemically react are called reactants, and the new substances formed after the chemical reaction, are called products. So what we are noticing here is, suppose if I am taking one example, take one illustration. So if I am taking one example, you take decomposition of limestone. If you take decomposition of limestone, here what we are noticing is, you take calcium, limestone is nothing but calcium carbonate. Calcium carbonate is a solid. So upon heating, you heat it, you get calcium oxide solid plus carbon dioxide gas. Calcium carbonate solid, upon heating it gives calcium oxide solid and carbon dioxide gas. This calcium oxide is also called quicklime. So you calculate the total mass of calcium carbonate. If you calculate the total mass of calcium carbonate, suppose if I am taking, say, that is rough calculation, if you make, the total molecular mass. So the molecular mass, what I can do here is I'll put it like this: molecular mass of calcium carbonate is, that is, calcium atomic weight is 40, atomic weight of calcium is 40, atomic weight of carbon is 12, and there are 3 oxygens, 16 3s are 48. So total it is going to become 100 grams. Molecular mass is 100 grams or 100 units, whatever. If you go for calcium, calcium atomic mass is 40 and sulfur is oxygen 60. So therefore it is going to become 56 grams. Carbon dioxide, carbon atomic weight of carbon is 12 and each oxygen atomic weight is 16, 16 to 32. So therefore 12 plus 32, it is going to become 44 grams. So the total mass of the reactants, must be equal to the total mass of the products. Reactants total mass is 100 grams and in the products the total mass is 56 plus 44 is again 100 grams. So reactants mass is 100 grams and the product mass is also 100 grams. So therefore the total mass of the reactants and products have been converted, and this here 100 grams is again the total mass of the product. So in this way we can conserve the mass of the reactant as well as mass of the product, and it is able to satisfy the condition of law of conservation of mass. Experiment to verify the law of conservation of mass, the next part of the discussion. Experiment to verify law of conservation of mass. If you go to the experiment to verify the law of conservation of mass, then here what we can do is you can take two compounds, we can take two substances. That is, one is we can take, that is sodium sulfate. We take sodium sulfate, and the other one is, that is barium chloride. Sodium sulfate formula Na2SO4, and another one is barium chloride. The formula of barium chloride is BaCl2. So what we are doing here is, you are just taking a small quantity of, say you are taking sodium sulfate is a solid, so you are taking a small test tube like this. This is the test tube, this is the test tube. In this we are filling the sodium sulfate solid. This is sodium sulfate, and from here you are trying to decant. You have a small barium sulfate bottle. This is barium sulfate bottle, and we try to take this is barium chloride. So here if you are taking 5 grams, then here you are taking 5 ml of barium chloride. So immediately you find that the reaction takes place. What is the kind of reaction which are taking place? You find that a white precipitate is formed on the test tube, because you find here sodium chloride is formed, sodium chloride settles at the bottom, and barium sulfate is formed, that is going to become the precipitate. So what we can do here is, the test tube more or less looks like this. It forms the white precipitate of barium sulfate, and you find a transparent layer like this. This is sodium chloride. So from this sodium chloride, what is the kind of reaction you can expect from this experiment? The sodium sulfate plus barium chloride, sodium sulfate plus barium chloride gives you, it is going to give, that is, you get barium sulfate plus sodium chloride. So whatever the amount of mass you are taking for the reactants, the same amount of mass we can expect for the products. Suppose for example if I am taking, say for example if I am taking 50 grams of sodium sulfate if I am taking, and here if I am taking 80 grams of barium chloride, then here you can take, or you can take here 5 grams and here you can take 8 grams of barium chloride, then you find that here, that is you can take here 7 grams of barium sulfate is formed, and here 6 grams of sodium chloride is formed. So whatever the mass is there on the reactant side, the total mass of the reactant must be equal to total mass of the products. So here 8 plus 5 is 13 grams, and again 7 grams plus 6 grams is again 13 grams. So therefore total mass of reactants and products remains conserved or remains constant. Remains conserved or remains that is constant. So this experiment very clearly makes us to understand how the mass is getting conserved in the case of reactants as well as products. Mind you, this weight whatever we are taking, this is only just for our convenience we are trying to take these weights, 5 grams of sodium sulfate and 8 grams of barium chloride. Again you are getting 7 grams of barium sulfate and 6 grams of sodium chloride, like that. It is not to scale, just for our convenience we are trying to take the values. So in this way we can experimentally prove and verify the law of conservation of mass. So now let us solve one small problem to make us understand the application of law of conservation of mass. Suppose if the question is like this: if 10 grams of calcium carbonate on heating is gives 5.6 grams of calcium oxide, then amount of carbon dioxide gas formed. So therefore first of all, to understand this question, what we need to do is, calcium carbonate is a solid, so you have to heat it. When you heat, you get calcium oxide solid and carbon dioxide gas is formed. So what you are noticing here is, initially we are taking 10 grams. On heating this 10 grams, it is giving away 5.6 grams of calcium oxide, but we don't know how much amount of carbon dioxide is formed. Only calcium oxide is the residue and carbon dioxide is a gas. So the amount of carbon dioxide formed must be equal to X. Let it be equal to X. So what I am doing here is, I will just put it in this way, in a simple pattern I will put it in this way, that is 10 grams of calcium carbonate is equal to 5.6 grams of calcium oxide plus 5.6 grams of calcium oxide plus, that is, X grams of carbon dioxide. So therefore simply you can take this as X is equal to 10.0 minus 5.6. So this is 4.4 grams. 4.4 grams. So X is equal to 4.4 grams of carbon dioxide is formed. That means out of 10 grams, 4.4 grams of carbon dioxide is formed and 5.6 grams of calcium oxide is formed. Again, if you are adding 4.4 and 5.6, you will get 10.0, which is nothing but the amount of mass present in the reactants is equal to amount of mass present in the products, and the total mass of the reactants as well as the products formed are getting conserved or they are remaining constant. Hence we have verified the law of conservation of mass.